Okay, so today we're going to talk about about the true definition of a parabola. So, parabolas. All right, so let's start out with the definition here. A parabola is not exactly what you've been led to believe it is. Instead, a parabola is the set of all points, and I'm going to use two words here that you might not have heard before. So it's a set of all points equidistant. I hope that's not one of the ones you haven't heard. From a focus and directrix. Did what?
Oh no, I was talking to you, sorry.
Okay. So a parabola is the set of all points that are equidistant from a focus and a directrix. Now a focus is a point. This one here is a point. And a directrix is a line. Either horizontal or vertical, depending on the type of parabola. So, it's all some great stuff. What we've talked about so far is parabolas in what's called vertex form. And you've also seen parabolas in general form. Today we're going to talk about standard form, so 3 different forms of parabolas. But the warm-up had a parabola that was in vertex form. And vertex form looks like y equals some number times x minus h quantity squared plus k, where the vertex is at hk. And so like the vertex tells you how much you need to move the regular parabola. So like on the warm-up, it was moving it right 4 and up 2 because it was x minus 4 quantity squared plus 2. In general, this is known as vertex form. You've also seen general form, where it's y equals x squared plus 2x plus 5. That's general form. And then today we're going to talk about standard form. And standard form is a little weird. So standard form looks like 4 times some number p times y minus k is equal to x minus h quantity squared. So yeah, this is awesome. Tuesday morning, everybody's back in school. Great. All right, so the A and the P, like why they use different letters for those two, I'm honestly not completely certain. I think it's because the 2 different forms were created at 2 different times in history. And so they're probably like, one is probably Arabic for something and the other is probably Latin for something. I have no idea. I could find out. But so how you would take it from vertex form into standard form is not that big a deal. But there is one problem that usually seems to cause trouble, and that's converting the A into the P. So let's take a look at an example here where you're given vertex form, and then we're going to convert it into standard form. So let's say that we have some parabola that is y is equal to 2 times x minus 2 quantity squared plus 3. Now if I ask you guys to remember from way back when in September, and I asked you guys to tell me how is this transformed from the parent graph? Anybody want to take a shot at that? Yeah, Key.
It's dilated by 2, goes to the right 2 and up 3.
Great. Is it flipped over the x-axis at all? How would you know if it were?
Pardon the interruption. 7th graders will not be testing today. Sorry about that.
Okay, so who knows when you guys are going to end up testing then. Okay, so if we want to transform this from vertex form, which is super helpful, it tells us that the regular parabola goes right 2, up 3, and then it's dilated by 2, meaning it's made skinnier. It's 2 times skinnier. If we're going to go from vertex form to standard form, what we're going to do here is just start moving a few things around. The first thing you need to move is this plus 3 so that it's over with the y. So you're going to do minus 3, minus 3. So y minus 3 is equal to 2 times x minus 2 quantity squared. And now it's already almost standard form. We just have to find a way of moving that 2 onto the other side.
Can't you divide by
Yeah, divide by 2 or multiply by 1/2. Both would be the same. In this case, I'm going to say multiply by 1/2 just because I want to get it so that it's not over anything. So I'm going to multiply by 1/2, multiply by 1/2, and I'll get 1/2 times y minus 3 is equal to x minus 2 quantity squared. Now the last thing that you need to do is find out what this p-value would have to be. So in order to do that, I'm going to set up a little equation to the side where I say 1/2 is equal to 4p, because this number in front is that. And so then divide both sides by 4, or multiply both sides by 1/4, and you get that p is equal to 1/8. I feel like I'm going super fast. Yeah. Okay, let me go one step further, and then I'll go back and redo the whole thing. Okay? So bear with me for one more step, and that one more step is that this here is really, this 1/2 is really 4 times 1/8 times y minus 3 x minus 2 quantity squared.
Can you go up and show that equation again?
Yeah.
Wait, why did you multiply by 1/2 instead of divide by 2?
Because in standard form, I don't have this as a fraction over anything. I have it as a number times in front. So multiplying by 1/2 and dividing by 2 are the same thing. It's just that I want to have it so that I have something in front of this instead of this as a fraction.
If we're working from vertex form, on vertex form, why are we bringing this up from the input?
Because the p tells you where the focus and the directrix are.
But I thought the P and K were the same thing.
They're related, but they're slightly different. A is the dilation factor, and P is the distance from the vertex to the focus or the directrix.
Okay, in that case, why are the 1/2 and the 4p on totally different sides if y minus k is on the same side as the 1/2?
Because I was trying to find out what P would have to be, since the number that's in front of this is 1/2. Like this 1/2 takes the place of 4p, so I need to find out what P is. So I do 1/2 is equal to 4p, and then P is equal to 1/8.
Okay.
Because I haven't changed anything down here. I'm saying 4 times 1/8, and 4 times 1/8 is 1/2. So 4 times 1/8 times y minus 3 equals x minus 2 quantity squared.
Okay.
And the reason that we're putting it that way is because now we have what this value p is. Like, all of this wrangling was to get everything to look from here like that.
We're going from
Vertex into standard. And you've also learned general before. General is if it were y equals 2x squared plus 5x minus 8. That would be standard form. Or sorry, general form. There's another one called like lattice form, and there's all kinds of stuff for this. So anyway.
Why don't mathematicians just get together and be like, what we're doing? One point.
This is what happened. Because there's different, like, depending on what you want. Okay. So it's easier for me to explain how functions transform if I give you vertex form, because then you can just know that it moves left or right, up or down. It's easier for you to find the focus and the directrix, because sometimes you need to know that if you're given standard form. Okay, so an example of why you might need to know the focus of the directrix. So I'm assuming since we're in a small town, everybody's seen a satellite dish before? Right, those 18-inch parabolic dishes? Those are parabolas, by the way, in case you didn't know. What they do is they take an equation of a parabola and then they rotate it, and then they create a three-dimensional image from that. There's actually an equation to your satellite dish. And the way that your satellite dish works out, the receiver, that little weird knob, is directly at the focus of that parabola. The reason why is because if anything hits this dish, it's going to reflect directly back to the focus. From any angle at all, it's going to reflect there. So the focus is very special as far as using parabolas go. And it's not just satellite dishes, there's all kinds of other things that parabolas are used for. You need to know the focus. Like concert halls, they used to be ellipses, but now, like, the way that the stage is set up is it's a parabola, so that any sound is being reflected back to the focus. You could even go to, like, ancient Roman amphitheaters, and if you stand directly in the focus, even though you're 100 yards away from the people who are performing, you can hear it perfectly. Because they're at the focus, because all sound is being directed to that kind of sort of. And so, like, if you imagine this as a theater, this is the focus of the theater, and everybody who's in this area can hear it just fine.
So then, why doesn't the receiver on the satellite or whatever, why doesn't that get super, super hot? Because wouldn't all the light be reflecting back to that?
Yeah, but if you notice, they're usually made of translucent plastic, which doesn't absorb light, it reflects it. And it's not the light that it's receiving so much as it is the, I want to make sure I'm saying the right thing. It's not infrared or X-rays, it's radio waves, but I don't think it's actually radio waves. Anyway, it's receiving the waves from the satellite that are projecting the television image in ones and zeros. Long string of them. Okay, anyway, back to this. So, that P that is given up there, that is the distance from the focus, or sorry, from the vertex to either the focus or the directrix. So let's imagine if I were to draw this out here. So I know that the center, or not the center, the vertex of this parabola is at 2, 3. So I'm going to go over 2 and up 3, right there. Now the parabola is going to go like that. It's going to open up, and we know that it opens up because there's no negative number in front of it. If P were negative, it would open down. Or if A were negative, it would open down. You guys remember that from way back when?
Wait, I thought P was less. Okay,
Less than 0?
Thing, yeah.
Yeah. Okay. Now the next thing that you need to do is take that P is equal to 1/8, and that means that 1/8 above is where the focus is, and 1/8 below hits the line of the directrix. It is. I should have chosen better numbers, but these are the ones I chose. So bear with me. If it's your your satellite dish at home, because it's so shallow, the focus is, I want to say, like 8 or 9 inches above. You what? You're over all of it?
All of it.
Okay. You get to be over it. So if I'm going 1/8 up from 2, 3, like what's 1/8 above 3? 3 and 1/8. Okay. So the focus is at, is it 2? Yeah, it's 2. 3 and 1/8.
Where'd you get the 2 from?
It's the x-coordinate right there. Since this is 2, 3, you're not going up or down, you're just going up.
Oh.
So the x-coordinate remains constant. And then if you go 1/8 down, it's 1/8 less than 3. 2 and 7/8. Yeah. So the directrix is this line, this horizontal line in this case, that goes through 2 and 7/8.
Why is that important? Just know that there's a line there?
Because the directrix and the focus are what create the parabola. Every point on that parabola is going to be the same distance away from the focus and the directrix. So like if I were to draw this out, at every point here, like if I were to pick a point right there, the distance from the focus to that point is the same as from that point to the directrix. And that's what creates a parabola. So you kind of been a little bit misled about exactly what a parabola is. A parabola, like when they were first creating or first discovering them, when they were first discovering them, they discovered them based on the focus and the directrix. But that's not how you're taught them. You're taught them that for class.
How exactly did they stumble upon it?
Because somebody was like, let's draw a line, let's put a point down, and let's find every point that's equidistant from those two.
I
That's
don't
silly.
like that person.
Okay.
Not at all.
That would be an ancient Greek. And then somewhere along the line, when people were rediscovering Greek texts, somebody was like, "Can we do this with an equation?" They did, and then they were like, "Let's make the equation all kinds of different forms," and they did. And then the easiest form was the one that they discovered last, so that's the one you get taught first.
I like that one.
Okay. All right. So, Oh yeah, let's talk about some other things here. So the parabola opens up. We know where its vertex is. We know its focus in Directrix. Axis of symmetry is the line that you can draw straight down the middle of the vertex to make it the same on both sides. Because symmetry means when something's the same on both sides. So the axis of symmetry for this guy here, I'll call it AOS.
I feel like I learned this last year.
Yeah, you've learned axis of symmetry before.
Oh, yeah. But what now?
That would have been either in Algebra 2 or
It was algebra 2.
geometry, depending on who you had, yeah.
I had John.
Okay.
So, how did you say?
The axis of symmetry is going to be a vertical line, and it's the vertical line that cuts the parabola directly in half. And since the x coordinate is 2, the axis of symmetry is x equals 2. It's that line that's vertical at x equals 2, and it cuts it directly in half, so it's the same on both sides. Because parabolas are symmetric. The other thing that you need to be able to find is the y-intercept. Okay, and to find the y-intercept, all you have to do is go back to the original equation, whichever form you want, vertex or standard, put in 0 for x, and then find out what y would have to be. So in this case, if you put 0 in for x, you have 0 minus 2, which is negative 2, squared is 4, times 2 is 8, plus 3 is 11. For the y-intercept. Because the y-intercept is where it touches the y-axis, and at that point, what is x? So if you wanted to find the x-intercept, you put 0 in for y, which is what we've done quite a bit, finding x-intercepts, because x-intercepts are the same thing as zeros, or the same thing as solutions. We've covered a lot this year. All right, so let's take a look at your homework, and I'll go through some of the problems with you guys. If you got that scared lamb with